Okay, Claude has a new thinking model, version 3.7 from Anthropic. I'd like to put it through its paces, but I want to do it via the Programmatic API. I want to access this thing with Java rather than Python or TypeScript. You're welcome to try those, but I want to show you how you can do that now, right away. Welcome to Tales from the Jar Side. Welcome. My name is Ken Kousen, and on Tales from the Jar Side, I try to give you expert advice on how to work with Java, Spring, AI, and related technologies. Let's take a look here, and we have Claude running in a browser. You can see right here there's a list of models in the drop-down, and the one I have it on is our most intelligent model yet, Claude 3.7. Also, you can see that for the thinking mode, that's the really new feature, they either have normal, which is best for most use cases, or extend, best for math and coding challenges. Now, if you take a look at the Programmatic API, this is at the Anthropic docs to access it programmatically. Here is a curl request showing that the endpoint you want to go to is api.anthropic.com/version1/messages, and there are several custom headers you need to add. Anthropic likes to put its API key under x-api-key, so there's a custom key you have to work with. They also require you to specify Anthropic version, and the value has never changed. And then there's a content type. Now in the body, this is actually going to be a post request, and you're going to specify the name of the model. They have not yet updated these docs to show the latest model. Instead, they're still talking about 3.5 Sonnet. So the max tokens there is something for the output, and the messages you send is an array of role content combinations. In this case, the role of user and the content is hello world. Okay, that's all well and good, and it doesn't say anything about the thinking model. With that in mind, let me access this programmatically using the API from LangChain4j. Now, if you're not familiar with it, LangChain4j is a nice little Java-based framework that's a rethinking of the concepts from LangChain, the original Python framework. And if I look in here at the integrations for the language models and go to Anthropic, it shows you the dependencies you have to add, and then you create an Anthropic chat model specifying the API key, the model name, and call generate, or these days you call chat. I think generate with the string is deprecated now. And there's a bunch of different properties you could put in. Let me show you that if we don't care about the thinking model, we could just do this right away. Here I have a JUnit 5 test case I'm calling Anthropic test. And I'm going to access this without the thinking model to make it nice and simple. The Anthropic chat model class implements the chat language model interface, and I'm not doing anything special, so I might as well use a reference of that type. I use the builder and set the API key to my Anthropic API key, which I have as an environment variable. And then here, model name is the way you specify which model you want, and that's overloaded to take either a string or a constant in the Anthropic chat model name class. Let me show you, obviously, that this string is going to have to be the one I use because they haven't had time to update it for the new one yet. So if I go into the source code here, you could see there's the overload of model name for a string, and here it is for Anthropic chat model name. And if I access that, you can see the constants up at the top go all the way back to Claude 2. Here's the Claude 3 series. Here's the Claude 3.5 series with Sonnet, Haiku, and then a later Sonnet model. But that's all we have. So obviously what I need to use is the string. I'm going to log the requests and responses just so you can see the complete input and output. And I'm going to ask this simple question. Now I could just put in a string here, but I want to see the full response. And I'm just going to put in the question that they add in their discussion about extended thinking. So the question they ask in their thinking discussion is, are there an infinite number of prime numbers such that n mod 4 is equal to 3? And I'll just print out the response. So let me run that one right now. Okay, so looking at the output, you can see this was in fact a post request to that endpoint. So we know what the endpoint is that we need to use. That worked out correctly. All the headers have been specified, including the XAPI key and the Anthropic version. LangChain4j does this for me. There's the model that we asked for. In the role of user, there's the text content I transmitted. And here is the response. Now, I'm going to skip through this, and you can see the output is an AI message. Yes, there are infinitely many prime numbers p such that p mod is equivalent or congruent to 3 modulo 4, and you can go on and read it if you're interested. This took me only a few seconds. Here it took less than 10 seconds to complete, which is pretty good. That's not going to be the case when we get to the thinking model. Okay, now back to the documentation. When you look at the API reference, under messages, you could see the endpoint that you send all the requests to and the required headers. The Anthropic beta, which is optional, Anthropic version is required, the XAPI key is required, and the body needs to specify the max number of output tokens and the messages, which is the array of input messages. But if I scroll down, and these are in alphabetical order, so I have to get down to the T's here. Here's the new one. It's called Thinking. Configuration for enabling Claude's extended thinking is what they're calling it. When enabled, responses include thinking content blocks showing Claude's thinking process before the final answer. Requires a minimum budget of 1024 tokens and counts towards your max tokens limit. See extended thinking for details. Sounds like a good idea. So here is the extended thinking section of their user guide, building with extended thinking. Extended thinking gives Claude 3.7 Sonnet enhanced reasoning capabilities for complex tasks, while also providing transparency into its step-by-step thought process before it delivers its final answer. So how does it work? You create a thinking content block where it outputs its internal reasoning, incorporates insights from this reasoning before crafting the final response. So let me scroll down, and now you will see here in the input request, everything up top is the same. We're sending the same headers, the key, the version, and then adding in the content type. That turns out to be required as well. We were transmitting application/JSON. And the data this time has a new block in it called Thinking, which has inside it a type of enabled and a budget token. So they raised their max tokens to 20,000 and budgeted 16,000 for the thinking process, and there's that question. When you submit that, here's the response. You get a content which now has this array, that's normal, and the first element of the array has these 2 blocks now. We are used to getting back a type of text with the answer in it, the text here, but now there's a type called Thinking, which says thinking to approach this, let's think about what we know about prime numbers, and this cryptographic signature, which is there to assure us that this was in fact generated by Anthropic. When you scroll down a bit, they talk about what this is for and about the signature field, just as I was explaining. And sometimes they'll flag things for safety, etc. Let me skip all that and skip the streaming part, and I'll simply point out a couple features here. First of all, the minimum budget is 1024. You have to give it at least that or it won't trigger the thinking model. They suggest starting at the minimum and increasing the thinking budget incrementally to find the optimal range for your particular use case. I'm going to use their example. Thinking budget is a target rather than a strict limit. Be prepared for potentially longer response times. Streaming's required when max tokens is greater than 21,333. Okay, fine. The pricing here, in case you're curious about that, extended thinking tokens count toward the context window only on a single question in a conversation, though, by the way, just on the current question, not on all of them, and are billed as output tokens. Since thinking tokens are treated as normal output tokens, they also count toward your rate limits. And then here are the costs again. Output tokens are $15 per million tokens. That's a lot. Sure, it's going to add up, but we're still talking fractions of a cent for most queries that you need to make. But it's something to be aware of. Okay, now I have a bit of a problem. And that problem is that LangChain4j doesn't know about any of this stuff. how am I therefore going to transmit the new thinking block and process the response coming out of it? Here's the way I'm going to handle it. It's true that LangChain4j does a ton of work for me, but it's already done all the mapping of the input requests and the output responses, and that's not going to help me because I need to add in additional fields into the input request and process the new fields on the output response, and I can't do that through their model. However, what LangChain4j is really doing is they're using the Jackson JSON parser and generator to do this in Java, and they're doing the networking through the OkHttp library. So I'll just use those libraries directly. So here we see in my test that's going to use the thinking part, I'm using their OkHttp client. Now you can dig into the library on OkHttp if you like. It's a library that's used extensively in the Android world, but it's not difficult. Now I normally would simply instantiate it, but remember they said this stuff can take longer? Yeah, the default timeout period is not nearly enough for what we need to do. The default timeout period is usually only about 10 seconds or at most half a minute waiting for the response. That's the read timeout. So I'm using their builder to set the connect timeout to a full minute, although I don't need that, and the uploading of the data to a minute, even though I don't need that either. The one I had to play with was the read timeout. Most of the queries I'm doing, and the one I'm going to do now, the one that was in their sample, took me just about 2 minutes to process. So I'm giving it a timeout of 3 minutes. And here is the object mapper class from Jackson JSON library. Nice and simple. So from that example, here is the JSON data that I want to transmit. I'm not mapping this to classes or records or anything right at the moment. I'm just going to hard code it in just to make sure I can get this to work. So there's the model, the max tokens, the thinking block with the token budget in there, and the same question we saw from before. What I'm going to do is use the OkHttp API to send this question, parsing it as JSON data, and make a request builder to the proper endpoint and add in all those headers. Now, I like to add in the accept header as well, saying I'm expecting back JSON data. I don't think that one's strictly necessary, but it certainly doesn't hurt anything. This key I already have as an environment variable, and that's reading it from my environment variable. When I execute a synchronous response, you create a new call and then invoke the execute method. If it's not successful, I'll print the code and just fail this test. Then I access the body, which I believe is not going to be null, read it as a string, say it's got the word thinking in it somewhere. And then here's the final piece of the puzzle. Rather than trying to map that to records or classes or anything either, which I imagine the LangChain4j people are going to do eventually. I mean, they'll take care of it for me. I could do it, but what the heck, let's just make sure it works. I'm going to call read tree, and read tree is going to deserialize the JSON content as a tree expressed using a set of JSON node instances and gives me the root of that tree. Then I can walk that tree, and it turns out I can use something called JSON pointer to make that pretty simple. So it turns out the section I want is the first element under content labeled thinking, as we saw in the JSON data. So I'll navigate down to that and print it. And then I'll also go to the text content and see the output there. And that's the whole thing. It's not trivial, but it's not exactly difficult. And it's the same stuff over and over again. Again, the reason we're doing this is because they have added additional features to the model on the input as well as that thinking block on the output. Now let me run this one. Let me make a couple quick comments while I wait for the output. First of all, those libraries I'm talking about are already part of LangChain4j. When you bring in LangChain4j as a dependency, you already have the OkHttp library in there and the Jackson JSON parser. If I was to do the same thing with, say, Spring AI, then I would use Spring's REST client, which is part of Spring, of course, the core of Spring. And again, I'd have the Jackson JSON API. So I could use those directly with the Spring app. If you don't want to use either framework, you just want to do this directly, then just add those dependencies to your build file, Gradle, Maven, or whatever you happen to use. Okay, let's take a look at what we got. So here's the thinking part. This question is asking about primes of the form 4k plus 3, where k is a non-negative integer, and on. And you can see that it's pretty extensive, the amount of output tokens I used here. And eventually I get to the actual output. When this finishes, then I get the rest. Yes, there are infinitely many prime numbers such that n mod 4 equals 3 or equivalent primes of the form 4k plus 3. And I'll prove this by contradiction using a method similar to Euclid's classic proof of the infinitude of primes. Yes, okay. Now, if I go to the very bottom here, you'll see that took 1 minute 42 seconds to complete. So I did have to bump up that output time, but it wasn't too bad, and I did get a decent response out of it. So that's really all there is to it. You can dig into the documentation and find out more about what to do with this, when you want to use it, when you don't. But you can start coding to it immediately. If you want to use their Python API or their JavaScript API, of course, you're welcome to do so. The reason I use Java is a framework like LangChain4j will make it very easy to manage, say, chat memory if I have a series of requests that I want to have a conversation with, or I can do function calling, which works really well, although I'm not sure the thinking model supports function calling yet. And I can do RAG. They have an excellent retrieval augmented generation mechanism as well. So I do want to use the framework. I do want to work with all my existing systems, and that it's not all that difficult to just go under the hood a little. I hope you found that valuable. Please consider liking and subscribing if you want to see additional tales from the jar side. Thank you very much.